Hello, Jovish. How are you?
I am fine. And you?
I'm doing well. So you look a little bit worried. So what's going on?
So you see, this is the construction site of one of my friend. He's printing 3D buildings for the houses.
Oh, interesting.
So he's doing this first time.
Okay.
So I told him before doing any project with huge money, do like some experiments with some prototypes.
Yes. Okay.
So I gave him the suggestions. Now I don't know how to do the prototypes and the experiments
Okay.
now.
I have a couple of minutes, so let's
Okay.
talk about it. Yeah, so it was a very good recommendation. So always that you are looking for like a new product,
Okay.
it's important to do some prototype to test, like quality, time, how
Okay.
much it will cost. So do you know what are the key objectives for him? So what he's looking for?
So he told me some of the optimal settings, but it is not important for him which one, but optimal settings, he want to minimize the print time and he need the high quality surface.
Okay, so he has like this machine to do the printing. So he wants to know, okay, what are the optimal values for the different settings, to minimize print time and high quality. Okay, that's good. So before we go to the experiment, so we need to be a little more specific. So what high quality means, so we need to have something to measure and also, optimal settings. So do you know what are these settings that he can control on the machine? So what are like the parameters of the machine?
Okay, he gave me a list of things that we can control.
Okay.
Those are like layer height, print speed. Okay, all these are the things we can control.
Okay. Okay, excellent. So these are, some of the settings of the machine, and I also see like ambient temperature and humidity that are, more in the, some other factors. So this in design of experiments, so we call it factors. So all the variables that you have and the ones that you can, control. And there are some of these factors that are hard to control. For example, ambient temperature and humidity, so it's very difficult to control. However, it is important to measure because, it can be some sort of correlation. Maybe, we use it as something we call like covariance. So you take a record of that, but it's very difficult, to control. So within all the factors, so we have control factors, or like the layer height, so we specify on the machine, the speed, etc. And then we have some other factors that are a little more difficult to control.
But if I consider all the factors, the experiment will be very large, no?
Yes, yeah, that's a good point. So when we are doing experiments, typically we select 2 to 3 factors, maybe the main one, because if you have 8, 10 factors, so then you will end up with hundreds of prototypes. So that, even it's a small prototype, it will cost money and time. So do you have any idea, which one will be of high priority?
Okay, this list in order of the priority. So let us choose the first 3, no?
Okay.
Layer height, print speed, and infill density.
Okay, excellent. So after you decide which factors you will control, then we need to know the values for these factors that we call it labels. So we need to check, say in this case, in the machine, and what are the specifications that he can go, or based on some previous experiment, we define it. So we now call factor A, B, and C for these 3 factors that we have. And any idea of what layer height could be?
Yeah, he told me the layer height, there is a range like from 0.1 to 0.3, and print speed is 40 to 80. He can go anywhere between.
Okay.
And infill density, it should be between 20 and 50.
Excellent. So these, these particular values, we will decide, which one to use, because as you mentioned, it's a range. So say for the layer height, so we have 0.1, maybe we test 0.2 and 0.3. So those will be the levels of that factor. In that case, so we may have 3 levels, and say for print speed, we have like 2 levels, low and high. Typically, it's balanced. If we have 3 levels, so we use the value in the middle. Not all the cases, but typically. And the same for the infill density. So we need to define how many levels do we want to test for each of the factors.
So to make sure that things that we can control are layer height, print speed, and infill density we call factors.
Yes.
And in each factor we choose two levels, like we
Yes.
can put 0.1 and 0.3.
Yes.
We have three factors. In each factors, we have two levels.
Yes.
Okay.
Yeah.
We can
then-
fix like that.
Yes. Let's do let's fix it to two levels each of the factors. Later we can decide if do
But the
more.
problem is I have to do all the combinations now.
Yes.
So which are the all the possible combinations in this case?
Okay, so before we go to see the combination, let me talk about a little bit of what we want to measure. So you told me that, he's interested in high quality surface, like the product, but we need to have something to measure that, because high quality will be just a little difficult. So we need to have like a quantity. So those are the response variables for our experiment. So how do you think we can measure time? Because he also was interested of minimizing time, like production time, and the high quality.
So print time,
Okay.
that is the one of the response, and
Okay.
roughness and the strength. So these are the three things we are interested in.
Okay, so the first one will be related to minimize the process time, and the other two are related to quality. So he wants, I'm guessing, like a smooth surface, so we want to minimize surface roughness and a high strength.
Okay.
Yeah, so now you have clear responses.
Three responses. I want to know all the three
Yes.
in each of the prototypes.
Yes, for each of the prototypes, you will need to measure
Okay.
these responses. So, okay, now let's go and see, which combinations that you will,
Okay.
were saying we need to run. So we have, different type of experimental designs that we call it. So these experimental designs will help us to analyze the relationship that is with the factors and the response. And depending of the objective and the nature of your experiment, we have, different forms to do the experiment. So the more famous one and the general is the factorial design. In the factorial design, you analyze all possible combinations, and they are used mainly to see if there is, these relations. So which factors really affect your response or not. We have some other experimental designs, like the central composite design, that will help you to build like a model to predict the values of your response on some levels that you didn't test, and is thinking more towards the optimization part. So we may start with a factorial design and then end up with a central composite to really define the settings that you want that optimize response. And we have, some other experiments like the mixture design, that these are common when you have some sort of recipe and you have a percentage of each ingredients, and the sum is 1 or 100 percent.
So in our case, which of these is best for our experiments?
Okay, so I would recommend going to the factorial design, because
Okay.
we are exploring. So that's
The
the
factors.
the factor that really
Okay,
affect
that makes sense.
your response. So we will start with that. And as I mentioned, so this will, analyze all possible combinations. But what's this of, combinations of factor levels? So let's see this case of two factors. Let's go to two factors, two levels. So here we have 4 points, the corners of this square, and you can see with factor or the combination A that it has 0, 0. So that means the lower level of your factor, maybe the lower level of speed and height, like 40, and I think speed and a layer 0.1. The letter D represents the high, like both factors at the high, and C and B
So
are
this
the mix.
is another case, no? You are explaining if we have two factors like A and B, and
Yes.
in each factor we have two levels, that is 2 to the power 2.
2, yes.
Okay, so but in our case we have like 3 factors, and in each factor we have 2 levels.
Yes.
So it should be 2 to the power 3, no?
Yes. So how many
Okay.
combinations
Like
should we have?
2 to the power 3 is 8.
8 combinations.
So I have 8 combinations. So
Yes.
which are the combinations? All
So for this case, now instead of having like a square, let's think like, like if we have like a cube. So all the corners represent one of the combinations. So in 8, so we have all at the lower level represented here by zeros.
This is easy to understand now, this table.
Yes, you have all the combinations.
Okay.
And then you can see like the edge, like the opposite is, all, positive. So now we need to replace that 0 and 1 by the
higher
actual
levels.
values.
Positive means a higher level, no?
Yes, positive is higher level. So 1 is higher level.
Okay.
And say for the speed, that was 80, and the lower is, 40. So you will need to replace those runs.
Okay. So I have to do the 8 experiments.
Yes. So you have
8 prototypes.
Yes. So here you have 8 different prototypes. However, it's important to mention that when you do the experiment, you need to have replicas. So you need to do more. So you have 8 different ones.
So these are the 8 experiments you say. So first I focus on my lower levels with height, then I go to the higher levels, 0.3. So 0.1, then 40, lower levels or zeros, 40s and 80s, lower levels and higher levels. Lower level, higher level, lower level, higher. Okay, so this is the all possible combinations. I have to make 8 prototypes and I have to measure the three response variables. I have to check.
Yes.
Okay, so let us make the 8 prototypes.
No, but wait, Jovish. Okay. Yeah, so you need to make 8 prototypes, but as I mentioned, so you need to have some replicas. So what replicas means?
I don't want replicas. I want only 8 prototypes.
No, you need to do some replicas. Why? Because imagine that you let's focus on the first combination. So you build that prototype and you measure the one of your responses was the time. Yeah, the time it takes. So we run it, say, one time, and you got 50 minutes. It took like 50 minutes.
Yes, that is possible.
Yes. So let's say that I also, okay, let's do it once more and then just check. So your second time you do it, so you get...
Totally possible.
Yeah, it's possible, but there is a big... a difference. So if later we want to know, okay, which is the best one, so what should I say, 50 or 78? I know it's possible because, there is variability in the process. So since this process and, almost all processes have variability, it's important to have replicas. So we can account for that variability, because if you have 1 point, if you remember when you use this equation to calculate variance or standard deviation, so you need to have several points. If you have 1 point, so you cannot estimate the variability. So now let's say that you run it 3 times, you got like 53. So then it's most likely it's more likely that your actual value is in the 50 range, but now with 3 points, so we take the average and this, an estimate of the values. But if you just have one, mine was a 50, but then in the other 80 or it was 78, so it's not that accurate. So it's always important to have replicas, one, to estimate variability for that condition, and also to have a more precision estimate of the time, in this case, that it takes to print a prototype with these combinations.
But here I am sure it is print time around 50, so can I just remove this prototype that gave me 78 minutes?
Not really. So what I would recommend is first go and check your records. Maybe you have like a typo, maybe it was 58 and you put 78. It could happen, especially when we have too many runs. So check, for that, or maybe you have a note that the machine stopped for some reason and the print time, it was a little longer because of that. But if you don't have reason to say, okay,
there is no any error in the procedure, then I have to keep it.
Yes, then you keep it, and then, we know that maybe for these settings, you have a high variability. So later, when we are designing which, like the settings of the factors, so maybe you like one, that minimize all these responses that I have, but also that has a low variability, because, that's important when we are building things, that it's, more constant, process.
So you are suggesting 3 replicas. I have to do this for 3 times.
Yes.
Means I have to do 24 prototypes.
Yes, prototypes. So 3 of each one. So that would be like the minimum. If you can do more, so then,
like
don't worry.
If I increment 1 level here, like in 3 factors. I have
Yes.
3 levels, like 3 to the power 3,
Yes.
and then 3 times replicas.
Yes.
It will be around 100.
Yes, around
No,
100.
no. Let us go with this, like
Okay,
24.
so let's do this, for now. So it's important that when you are defining your experiment, the number of factors and the levels, take into consideration that, because sometimes people say, okay, I want to test these 6 factors, and then I want to do 3, 4 levels. So one single replica of the experiment can get huge.
Okay.
So yeah, that's very, very important. So when you are talking about with your friend, and if he say, oh, why not including this? So please tell him we can do it, but it will
It will
take
be
more
expensive.
time and yeah,
And all them, okay.
so yeah. So now here we have the table with the 24.
But this is not in the order. Why you change like 0.1, then 0.3? Why I shouldn't do all 0.1, then all the 0.3s? So why this
Yeah, so
not in order?
Yes, so this is called a randomized
Okay.
design, a
Okay.
complete randomized design. So that's important to minimize some of the bias. Imagine, we're discussing earlier that humidity or the ambient temperature can affect, the product, because
okay.
these materials absorb humidity. So imagine that first you have all the values at low, and you
Okay.
run it one day, there was, raining, so a lot of humidity. Then next week you perform the rest of the experiment and it was sunny, so really low humidity. Then your results may be biased because of those other factors that may affect. Now, if we do it random, so meaning that the day that was raining, so you have low and high values for the layer and the speed or the density, and for the other one, then we average things so that is minimized. So it's always important to do it.
Your
at random.
suggestions are 3 replicas
Yes.
and do the randomness. So 2
Yes.
things are very important.
Yes.
Oh, okay.
Yeah. So there are very, very important things when you are performing an experiment.
But you remember we have like 3 things now: print time, surface roughness, and strength.
Yes.
There is any randomness in those?
So it will depend of your experiment. For some experiments, really doesn't matter which one you measure first. But in this case, when you do the testing for the strength, so you will have like an impact test, your prototype will be destroyed. So I would recommend measuring first the surface roughness and the time. The time it really doesn't matter, because that you can, when you finish, you record the time it took.
So first I check print time.
Yes.
I put like print time, then I put the surface roughness,
Yes.
then I put the strength.
Yes.
If the first prototype, I record print time, surface, and strength in that order.
Yes.
Then I go for the next one. So I will do all these 24 prototypes and all this data.
Yes.
That will be my answer.
Yeah, so your answer later when we analyze. So first, be sure that, tell your friend that when he's building or doing the experiment, so do it as close as possible, each prototype, like the way he handled the, the material and all the other settings need to be on the same value. So you run it, then you have these 3 columns with the new data. So then we will need to do some plots to visualize. Then we do some statistical analysis. Then we can conclude if, say, factor A, like the layer, has an impact on the print time, on the surface roughness, and the strength. And how is that impact? Maybe, high layers, it will take more time to print, or like the speed, most probably the speed, higher speed will take less printing time, because it will be faster. But when you have the data, we can do these plots, also we can analyze the interaction, if there is an interaction between, these factors, and, see what we can conclude. Okay. But we need to look at the data and see, the things that we find out with the responses.
So give me 2 weeks. So you told me I have to do in random, no?
Yes,
in different times. So give me
Yes.
2 weeks to do all of these in
Okay.
random order. Then I will fill the table. then I will come back with you to check the results.
Yeah, perfect. Yeah, I will be
Okay.
eager to see the results,
Okay.
and so we can help your friend to
Okay.
decide which of these prototype is better. So then he can build the actual house in the actual dimensions and corroborate
Okay.
these
So
things.
now I understand he can use the optimal settings. What he mean by optimal settings?
Yes, yes. So
Okay.
we'll need to find, the settings,
settings.
for these factors that we are
Okay.
analyzing. So yes, so go back to the lab, do the experiments, come back, and we do the analysis.
Okay. Then thank you very much for your time.
Yes,
Bye.
nice to see you. Bye.
Okay. Bye.